So let us see what is real numbers. In 9th standard and 8th standard, you studied about rational number in the form of p by q, irrational number which cannot be written in the form of p by q, and we studied also how to denote both of these numbers on a number line. Number line is also called a real number. So let's see some importance of this natural number. First of all, we see what is natural number. It is denoted by capital letter N. 1, 2, 3, 4, etc. are called a natural number. We are also saying they are counting numbers. So what is a prime number? Prime number and composite numbers are actually the properties of natural numbers. So let's see what is prime number. Natural numbers having only two factors. Example 2, you know that 1 and 2 are only two factors. Similarly 3, 5, etc. If p is a prime number, then the factors are 1 and p. Now what is composite numbers? They are having more than two factors. Smallest number is 4. There are 3 factors. Now here 4 factors like that. 9 is the smallest odd composite number. We already learned these type of things. 1 is neither prime nor composite because 1 having only one factor. 2 factor required for a prime number, more than 2 required for a composite number, but 1 having only one factor. So it is not a prime also, not a composite also. Every composite number can be expressed as product of prime. You take any composite number, you can write the product of prime numbers. 2 and 5 are prime numbers, 10 is a composite number, 10 is equal to 2 into 5, similarly 20, 36, like that. So here the importance of LCM and HCF coming, we already learned in early years, but here we are doing this expression, every composite number can be expressed product of prime numbers. So 20 is equal to 2 into 2 into 5, already written there, 36 also like that. So HCF means highest common factor. Here you may see that 2 and 2. Here repeating, here also 2 and 2 only repeating. So HCF is 4. LCM is that 4 into the remaining product of numbers. Now let us see some importance of this HCF and LCM. You see that for two numbers, HCF into LCM is equal to product of numbers. It is only for two numbers, not more than two numbers. For 3 numbers it is not possible, not necessary to possible. Some of the cases may be, but not all the cases. So here you see just now we are written that HCF of 20, 36 is 4. LCM is 180. You may see that 20 into 36 is also 720 and 4 into 180 also 720. So that is one of the important thing for two numbers. Now HCF is a factor of LCM. It is compulsory that HCF is always a factor of LCM. Suppose you are taking two numbers, somebody is saying that their HCF is 25 and LCM is 60. It is not possible because 25 is not a factor of 60. Now, so I am finding 3 numbers HCF and LCM. So you will factorize, and everywhere common is that is HCF. 2 here, common, so it is HCF 4. LCM is this 4 you write, means all the common factors you write. Then, if anywhere 2 numbers having a common factor, that you write only once. That is why 5 is written only once. 1 of the 3 is only written once. And the third 3 is not anywhere, so that also multiplied, so 180. So this is for 3 numbers. Now let us see some problems. Now suppose a word, see a question is written. In a school, 32 students are in section and 36 in B. Find the number of books required so that they can distribute it equally. It means minimum number. So minimum, least, these type of things in a word problem means we have to find out the LCM. Similarly, maximum is word is there, then we have to find out the HCF. Here is LCM is calculated 288. So 288 numbers are 288 books are required. There is another problem show that root 2 is irrational. Let root 2 is rational. Squaring root 2 is equal to b by q. P comma q are co-prime. Co-prime means there is no common factor other than 1. That is the meaning of co-prime. So I square 2 is equal to p square upon q square. Implies q square is equal to p square. Implies means from here we are getting this, from here we are getting like this. 2 divides p square. 2 divides p. So since 2 divides p, so we can write that p is equal to 2 into any other number. That is p square is equal to 4r square squaring. So here also p square, here also p square. This p square value I substituted here. This p square value substituted. 2q square is equal to 4r square. Implies q square equal to 2r square. It means 2 divides q. Is it 2 divides p? 2 divides q, which is not possible because we took p and q are co-prime. So 2 is a common factor coming there. So 2 is a common factor in both p and q. It is not possible because our assumption is wrong. Therefore, root 2 is irrational. Now, if any question is coming instead of root 2, root 3 is coming, you change this 2 as 3. Here also 3, here also 3, here 3, here 3, here 3. But this will come 9 because squaring both sides. So you will get here 9. So here you will get 3 and here 9. So this 2 and 4 changes to 3 and 9. Similarly for any other number, 5 is coming like that. That number is only change, everything is similar method. Now let's see a polynomial chapter number 2. Algebraic expression having one variable in which power of the variable is a whole number, which we learned in 9th standard. That is called a polynomial. Example, p of x equal to x cube minus 3x square plus 5x minus 6. You will see the variable power, all these variable power must be whole number. And the highest power is equal to degree that you learned in early classes. 0 of a polynomial means what are the values of x which makes this complete polynomial 0 is called 0 of the polynomial. 0 of the polynomial 0 is also called root. Here you see that if you are putting x is equal to 2 here, x is equal to 2 here, this complete polynomial becomes 0. So I can say x is equal to 2 is a 0 of this polynomial. So now graphically how can you find out the number of zeros? So if a graph is given, number of times the polynomial cut or touch, it can be touch also. X-axis is called it's 0. So here I can see the zeros are minus 2, minus 1, 1 by 2. 1 comma 0 is not there because at 1 it is not cutting or touching. So 3, 5 zeros. You can say 1, 2, 3, 4, 5 zeros are here. Now why I wrote here 1 comma 0? 1 comma 0 means when I am putting x is equal to 1 in this polynomial, when I am putting x in this polynomial 1, at that time what is the value of p of x that is written here 1 comma 5. 5 is actually coming here. This is 5. So when I am putting x is equal to 1, since it is x-axis, that is 1 comma 0 is written. That x value put on the polynomial, not in this polynomial, the polynomial whatever is formed here. If I put it, then the value of the polynomial becomes 5. That is why this point is written 1 comma 5. Now quadratic polynomial with the degree 2 is quadratic polynomial. Its general form is p of x is equal to x square plus bx plus c. Maximum it may have 2 zeros. Let us see what are the importance of these zeros or how the graph will form. Let us see. Here some of the forms of quadratic polynomial is formed here. Quadratic polynomial is always forming a parabola. Parabola having two shapes having, one is in the upper direction or in the downward direction. So here you can see there are two zeros, here also two zeros, here one zero is touching, it is touching, we made it like that, here no zeros. So here I wrote this zeros means 1 comma 0 means x value is 1, y value is 0, means x1 when you are putting, you will get the value of the polynomial 0. That is why 1 is 0 roots of the polynomial. Similarly, if I am putting x is equal to 3, then the value of the polynomial is 0. But when I am putting x is equal to 2, the value will come minus 5. The value will come minus 5, that is written here. Or I am putting x is equal to 2, you will get that polynomial minus 5. That's a mean. Now, if p of x is equal to x square minus x square plus bx, a square plus bx plus c, a not equal to 0 be the polynomial, then this zeros having some relations. So if I am taking alpha and beta are zeros or roots, then sum of the zeros, that is alpha plus beta, is always minus b by a, minus b by a. B is the coefficient of x and a is the coefficient of x square. And product of the zeros is c by a. So suppose this alpha, in this case I took that, alpha is equal to 1, beta is equal to 3. Then I will get alpha plus beta is equal to 4, alpha beta is equal to 3. Then the polynomial also we can write. This is the format. If you know sum and product, the polynomial is p of x is equal to x square minus sum of this the format x square minus sum of the zeros into x plus product. This is the format of the quadratic polynomial. So here I took directly only. So if I am putting x is equal to, let us see minus 5 is coming or not, I wrote like this. So x is equal to 2 in this polynomial I am putting, then it will come 4 plus 3, 7 minus 20, so not minus 5 it is coming, so it is coming minus 30. That is, I roughly wrote that is why. So later on when I got the polynomial, I exactly find out what is the number. So you may see 4 plus 3 minus 4 plus 3 minus 8. Minus 1 is okay. So I wrote that, that's all the thing. Just you see that. Here I wrote one example. So you must know this identity, alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. This identity, alpha minus beta the whole square equal to alpha plus beta the whole square minus 4 alpha. These two identities are very important for your examination purpose, that is why it is written. One example I wrote here, if alpha and beta are zeros of p of x equal to x square minus 3x minus 4, a1, b minus 3, c minus 4. So you may see that alpha plus beta is equal to minus b by a, substitute it will come minus 3. Similarly, alpha beta is equal to c by a. If I am writing c by a here, then it will come minus 4. So alpha square plus beta square, if I am putting in this formula, 3 square is 9 minus 2 into minus 4. 2 into minus 4, that is 9 plus 8, 17. Alpha minus beta is equal to 9 plus 16 is equal to 25. If I want alpha minus beta, then answer may be 5 also minus 5 also. In case alpha is greater than beta, then only 5 will take. Otherwise minus 5 is also possible. And here also you may say that if I am, you see this sum and this sum alpha plus beta, if I am taking alpha plus beta is 3 and alpha beta is equal to minus 4, you may say the same polynomial will come as I explained earlier, p of x is equal to x square minus sum of the polynomial, that is minus 3 into x plus product means minus 4 is the formula. But you may see that the same zeros may contain infinite number of polynomials. So how many such polynomials are possible? There are an infinite number of polynomials, means if you multiply any number other than 0 with this complete polynomial, the zeros of the polynomial remain same, sum remains the same, product remains the same. So that is why we can write infinite number of polynomials with the same zeros. Some more examples I will explain, so that the rest of the things you must take from your notes which I already gave. Some other importance. If one zero of the quadratic polynomial is the negative of the other, means if I am taking one as alpha, then the other will come minus alpha. If I in that case, if I am taking the sum means alpha plus minus alpha, it will come 0. That is equal to minus b by a because my sum of the zeros is minus b by a. So b will be always 0. So if 1, 0 is the negative of the other, then b means coefficient of x always 0. Similarly, if 1, 0 is the reciprocal of the other, means if I am taking one as alpha and other as 1 by alpha, reciprocal. So product of the zeros will come 1. So c by a means cross multiplying c is equal to a. So here also product you can take, there is no use, that is why I am not taken the product. But here sum also I didn't take because there is no use for sum. Here sum having uses, here product having uses. So like 1, 0 is 5 times the other, then sum also you can find out, product of the you can find out. Sum having more uses because 6 alpha, alpha you will get. Alpha means one of the 0 you will get. Here also you make it, but here there can be 2 0. That is the usually product does not have any. Now you may see the various type of questions which you already explained in the classes, and you may see some of the things I will give you later.